Welcome to the 11th video in the series of video on current electricity. In this video we're going to talk about EMF and internal resistance. So let's start with a simulation from PHET. So let's assume this is your battery, and if you find the voltage across the battery when there is no current, you find that that's about 9 volts. So the voltage when no current is drawn is 9 volts, and this is what we call as EMF, or electromotive force. So we call this as EMF, which is voltage when no current is drawn, is a EMF. If the battery is an ideal battery, then the battery will not have any resistance of itself, but it is possible that a battery can have some resistance of itself, and this resistance has no effect when the current is not being drawn. So in spite of this resistance, if you calculate the potential difference across the battery, it will still be 9 volts. That's because no current is drawn, so all the energy is available for the in the battery, which is due to the chemical reaction. So now let's build this circuit. And attach a light bulb of 10 ohm resistance, connect the wires. Here you go, we are almost done connecting the last wire. As soon as we connect, the electric field will be established and the current will start flowing. So there you go, that's electron and this is current. And let's find out the voltage across this now. What we get is less than 9 volts. What we get is 8.18 volts. To just get this number right, a little bit more exact number. So let's say the resistance of the bulb is 9 ohms. So this is a scenario. So you have only 8.1 volts available of the 9 volts. So let's see what happens. So here you go. This is a symbolic representation of what we had previously in the simulation. So let's draw the potential diagram. So between the battery, there are two things that's happening. You're gaining about 9 volts, 9 joules for every coulomb, but you're also losing some energy due to this 1 ohm internal resistance. So this is as if you can imagine this 1 ohm as just a resistor added in series, so that you can do it just like a normal problem. So what will happen is you get a 9 volts of energy, but then you lose about, if the net current in the circuit is I, you lose about IR. This much energy you lose in the battery itself. So the net energy which is available would be, if this is E minus IR is the net energy available, and this we call it as terminal voltage. This is a voltage that will be between these two ends. So you get 9 but you lose some between these 2 points, between A and let's say B. Oh, by the way, these labelings are I put this resistance here. I should have put this resistance maybe maybe this labeling could be between A, this could be A and B, right? So this is literally not those points, but you can virtually say this is A and B. So now that's terminal voltage, and rest of it will be the loss due to the resistance R1. So R1, the loss will be IR1. When you get such a problem, you do exactly the same way. You find, the first thing you got to do is to find your R net, and your R net would be equal to 9 ohms of R1 plus 1 ohm of internal resistance. So this is your R1 and this is your R. So that's equal to 10 ohms. The second thing is you find I, which is E by R net. That's given by 9 by 10. That's 0.9 amperes. So that there you go, that you have 0.9 amperes. And third one is your terminal voltage is given by, you can either say it is E minus IR. Let's say you always use that. So this is 9 minus 0.9 into 1. That's 8.1 volts. So that is what is available for your, that's what is available, and that will be exactly what will be consumed by that resistor also. So if you multiply 0.9 divided by 9, you will get 8.1, which is same as a terminal voltage. Let's go back to simulation. There you go. So that's your 8.1 volts. So I hope you this made sense to you and you enjoyed this video. You can do one more problem. One problem as homework yourself. Here you go. So you have a case wherein you have a battery which is 2 volts and 1.2 ohms. You have a parallel resistor here which is 4.5 ohm and 9 ohm, and also you have another resistor here which is 0.8 ohms. You have to find the net current in the circuit. So A, find net current, find the terminal voltage, which is the potential difference across the cells, and also find PD across all resistors. So this you should get it as 1.2 volts. The terminal voltage should be 1.52 volts, and the net current would be 0.4 amperes. So try this problem. I hope you really enjoyed this video as much as I enjoyed making it. See you until the next one. Bye.